Music theory with Microsoft Excel. Negative modal distance intervals with negative distances over an octave. That's over 12 notes in the negative direction, because direction is actually a thing. So get ready and some coffee, because you ain't never seen rockin' unless you excel at rockin'. And for that, you need Microsoft Excel. We are in Excel. If you don't have access to this workbook, that's okay, because we basically built this from a blank worksheet but started in a prior presentation. So if you want to build this entire worksheet from a blank sheet, you could begin back there, or just build the part of the worksheet that we're currently working on. If you do have access to this workbook though, 4 tabs down below: fretboard, example, practice, blank. The fretboard tab having a simulated fretboard, we will refer to. The example tab, in essence, the answer key. The practice tab having pre-formatted cells, so you could practice the practice problem with less Excel formatting. But if you don't have any of that, that's okay, because we'll be working in the blank tab, where we started from scratch with a blank worksheet, and we'll be continuing, in essence, in the blank part of the worksheet, practicing both our Excel skills and music theory skills at the same time. Let's go on over to the fretboard tab, remembering what we're trying to do here. We're trying to be measuring distances, typically named intervals. However, I'm going to add and include the concept of modal distances, or modal distance intervals, if you want to think of them that way, to help us not be distracted and pulled out of the optimal way to visualize the fretboard, which is a map of the territory. The fretboard having 7 continent locations similar to the globe. We're going to have 5 non-continent locations, like the oceans that we go through to get to the continent locations, the destinations. Our head above the guitar, above the low or heavy E string right here, the one closest to the ceiling, is like us in space, looking at the fretboard, which is rotating around in a circle, applying 12 degrees of rotation as we're over in space, the fretboard world. And then we're going to be working in the degree of the C major and the collection of notes, 7 continents related to it. But if we were to move the whole thing up to C sharp, to D sharp, the whole thing would simply rotate like the world spinning around. And therefore, once I know what degree of vision I'm looking at, then I no longer want to name the points by the note names, but rather by the thing that stays the same as the world turns. That being similar to the Nashville number system, which is basically naming the modes: Ionian, Lydian, Phrygian, Aeolian, and so on and so forth. Problem, however, scale degrees mess us up. Scale degrees are in the chord names. Scale degrees are in the interval names. So when you hear scale degree, I think of it almost like I'm talking to a super progressive person, right? And they're telling me a bunch of stuff, and I'm like, how far is this distance to that distance? And they're like, blah, blah, blah. They called me all kind of insults that are kind of veiled insults with language that I don't understand, but I'm just trying to get the point of it. I think there's actual information in all the garbage they're saying. And if you get it, you're like, oh, wait a sec. Yeah, no, that just means it's 4 notes away. I just want to see it's 4 notes away. I don't care about your scale degrees. I don't care about, what you're calling me or what you're implying or all that. Just, can we get to the point of the conversation? It's 4 notes away. That's the important bit. Everything else you can basically ignore for the most part, right? That's kind of what we're doing here. So similarly, if we go backwards, we don't have really a great term for it with the scale degrees. The scale degrees are forcing me out of seeing this as just a node, just a point that we're measuring from. So I would recommend then not getting rid of intervals or scale degrees in your mind, but adding the concept of a modal distance idea. And that's just going to mean we're going to measure it from that node without having to rename the node in order to get the distance. So I can measure it by half steps to get over here, or I could say it's going to be 2 nodes up, 2 nodal half steps up. So we're going to compare the current interval construction to that structure of just simple measurements, as a normal, plumber would do if they're trying to figure out how much pipe they need to put in something. You're going to put the tape measure, and you're not going to use a scale degree. You're going to measure from the end of it. I don't need to rename. Anyway, So that's what we're going to do. If I go over to the example tab, remember our analogy here. So this is what I would call position number 1 on the fretboard, where we would be on the continents, continent, 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 and then the 5, 7, 8, and then the 5 gives us our continents. The oceans are in between. We can hit the oceans, but that's not the destination location. If we put that in a circle, it just so happens to work out in this way, and we can think of our directionality, our intervals, or our modal distance interval notations as being, if I'm going from this 2, for example, to this 5, I'm going 1, 2, 3 continents up, because the continents are in order in our example. They only go around the block. So that means I would call that 3 modal half steps up, a modal distance of 3 modal half steps up. Scale degree would be 1, 2, 3, 4, right? Scale degree is always going to be off by 1 if you do that funny measurement. We can also add the note distance equivalent, add in the oceans. 1, 2, 3, 4, 5 notes up. I can also go in reverse order. 1, 2, 3, 4, -4 continents or nodal half steps backwards, which would be 1, 2, 3, 4, 5, -5 scale degrees, except they don't usually use scale degrees going backwards, which is weird. So we have a kind of an issue there. And then we could add the continents. 1, 2, 3, 4, 5, 6, 7. 7 actual negative notes backwards. So that's our issue. Now note that we could also go around a circle and then some. So I could go backwards 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11. So I went around the block from a clock face standpoint. I just kept going around the block. But in reality, we actually have directionality and repetition. So we have a number line kind of concept that goes on forever, as well as a clock concept that repeats, which really means we're talking about like a spiral thing, right? So we want to add both of those concepts in such a way that would be more efficient than the scale degree concept, which completely falls apart when you go backwards, and have it account for the fact that if we go past an octave, it still works, right? All right, so that's going to be it. So we're over here in the blank tab where we took our notes and then we built the 7 notes in the key of C, noting that all other notes are relatively the same if you just change the perspective on it as the world turns, as the fretboard rotates. Then we looked at our normal distances, which is going to be, that means if I just go upwards distance-wise, like on a ruler, you can have distances of 11 different distances that we could name. Now, the current naming convention named them based on the ones that fall in the major scale, and all the rest kind of got dumped into a minor, basically, that didn't fall into the major scale. In essence, that's the down and dirty analogy or explanation of it. Now, that's not actually the best way to do it. Notice that we're adding context here with the scale degree positions. The second letter is a scale degree position. So the context could be useful in some cases, but it's actually limiting as well, because you don't always want to be in a scale degree. It's actually, you almost never want to be actually in a scale degree if you were to think about it properly, because you're measuring from a particular node. So I don't want to totally lose these concepts, but I would recommend adding the concept of a modal range, looking at it by distance of modal range, and looking at the modal distance, you can call them intervals, modal distance intervals, as opposed to scale degree intervals, right? And these will actually make more sense, but they're not going to be used as much, but I think they're useful. So then we said, okay, well, what if I go backwards? If I go in the negative direction, notice the scale degrees fall apart, because if we're in the key of C and like the C is the 1, then if that's the 1, it would go 1, 2, 3, 4, 5, 6, 7, and you could keep going and call this the 8, 9, 10. But what people typically do is they say that's the 1 an octave up. So we talked about that idea. If I go up past that point, then I'm going to still call it like this major third. I'm going to call it a 4-note away plus an octave, 16 notes away, or a 16-note away major third. Now you could call it a major 10 scale degree, But I don't think most people do that. Most people are just going to call it a major third, particularly guitarists. And so, and to be more descriptive and kind, I would recommend getting in the habit of naming the distance in notes as well as scale degree. But when you go to the negative direction, like if I'm on this 1 and I go backwards, you would think that would be 1 step in the negative direction if we were measuring distance, and you would call it then a -2nd scale degree. But they don't do that, in part because it doesn't make any sense, because it's all off by 1. You can't see the inverse distance. So that's why when I went backwards, we have to start to memorize that, well, if I go backwards and I think about it as a clock face, that would be getting me to the same location as if I went 11 forward, which is a -7. So I would think of a -7 as either being going 11 forward or 1 backwards, even though that's not exactly how a lot of people see it, which becomes a problem for a lot of people because they don't there's no real there doesn't seem to be a uniform terminology for going backwards because you lose the scale degrees, right? And then if you go over an octave, you have the same thing. So I would recommend under the scale degree system to say the notes that are forward and backwards and try to keep the same flavor. But we can also add to that a more precise system, which would be measuring by the node. So then we also said that we could say, name the ranges that we're in by the continents going forward. So if I'm in the Ionian node, I can say I'm going Ionian to Ionian, or Ionian to Dorian, Ionian to Phrygian, which from a Nashville number system would be like a 1-3. So it would be a 4 note away Ionian second modal half step, which would be the 3rd scale degree. See how you can add this onto your thinking, because this actually makes more sense from a measurement standpoint and doesn't pull you out of a nodal thought process. It doesn't make you keep thinking you're on different scales. All right. And so we saw that if we go above 12 here, then again, we can do the same thing. I would recommend that we add the notes, but then we kind of think of the modal half steps as though they're going around a clock face, similar to the scale degrees. Now, I'll give another presentation where I could have these continue to go up, just like with the scale degrees, just like having this one go up to like a major 10, right? Scale degree. We could have this go up, but I think practically, functionally, it's easier to name the note distance as well as the distance, modal distance in half steps that are on a clock face, instead of them keeping going up, because that gives you the flavor as well as the distance in 1. But you could do it either way. Now going backwards, if I went in reverse order, notice this makes more sense, right? Because if I go 1 step back from the Ionian node, then I can call that a -1 from the Ionian node, 1st modal half step, which would be the 2nd scale degree if we had scale degrees. But they don't have scale degrees, so we just keep it as a major 7. But this makes sense, because then if I reverse it, what would it be? It would be 12 minus 1 would be 11, and then 7 minus 1 would be 6. So if I went forward around a clock face, then we'd get an 11 note away from the Ionian node, 6 modal half step, which would be the 7th scale degree. See how that makes sense, right? If I go back 1 or back 1 note or 1 modal half step, that would mean that I would go forward 12 minus 1, 11, and 7 minus 1, 6 modal half steps forward. Just distance-wise, if you're a plumber measuring how much pipe you need, that's how you do the measurement. That's how normal people measure things, okay? But if I continue past this point, then we have the same kind of issue. Now I'm going past an octave in the negative direction, except it makes more sense here. We're just going to continue the idea, and I'm going to do the same thing we did going forward, meaning I'm going to actually label the distance, even though it's going past 11, past an octave in the note side, but I'm not going to keep on going in the negative direction from a modal half step degree. Why? Because I'm going to imagine I'm going around the clock face with the modal half steps, because that will give me the same flavor number that I can start to associate more clearly with the flavor of the interval, even though it's a larger distance by 12, right? But we can also do it the other way, and I'll show another table to do it the other way as well, which is more mathematically consistent. I think this is more logistically easier. All right, let's make this bit blue up top to match what we have over there so I can work with this. So we're going to say, all right, so what if I go back? I'm going to go back past negative 11. This is going to go back to an II modal range because it's going to repeat from a clock face standpoint as we go around in a circle. So it's still going to be an II, but I'm going to say it has and 12 or negative 12 in between them. In other words, if I go from I to I, if I was up here going from I to I would be in the same spot, but really I'm going I around backwards to I. So if I see it this way, I'm on this I, and if I stayed on the same spot, I would be going from I to I. I could go forward then 12 notes to get to another I, but no, I'm saying I'm going backwards 12 notes, so it repeats from a clock face standpoint, I back to I. So that gives us the two endpoints as well as the distance that's going to be added to it in terms of an octave. So we can do that with a Nashville number system format, which means it would be going from 1 to 1, and then once again I'm going to say and we're adding a negative 12. So we have a distance going from 1 to 1, which is I to I, and a negative 12. From a distance perspective, then what is that going to be? I'm going to say that's going to be a 12 note away now because it would be 0. I had a 0 note away from the Ionian node, 0 modal half steps away. Now we're going to say it's going to be, let's say, negative 12, and then it's going to be I 0. Now you might say, well, hey, I should say negative 12 I 7 or something like that for a negative 7. But once again, I'm going to keep this second number as though we're going around in a clock instead of going distance-wise. And I'm going to have the 12 number going up in a number line. And that means that the second number will always be one that kind of gives me the flavor that is within 1 octave, but still gives me the distance. I will do another table to repeat this because you might have a system where you want to drop the notes. That's what we do over here. We drop the note names and we just call it a minor second or something like that. So if you wanted to do that, it would be more specific than if you just kept the distance in modal half steps going up. So you could do that, and that could be useful, but so I'll show you that. But I think this is the more practical way to do it, although it's a little bit longer to say that. So then let's do one more, and then we'll think about how to do the formula to make this as easy as possible. So the next one up, I went from II, and then I'm going to the IN is the next one up. So we go then up to IN, which is still in the same key, but now I'm going to say and it's going to be a negative 12. So IN and a negative 12. So meaning I'm going from I to N, but really I'm going I and then up another 12 notes like in between to the N that would be up here from a modal half step. If I was over here, we're going I, let's go to this I down here, I down to here, not to that N, that would be one step back, but I'm still going to get to N by going around the clock face, right? So I got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, another 12 back here. So that's going to be total distance of 13, I believe, right? It'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Boom. All right. And so that's going to be our distance. So we're going to say then I could write that this way by saying this is going to be a Nashville number system going from the 1, which is the Ionian, to the 7, which is the Locrian, and negative 12, meaning that would tell me that I'm going backwards and there's another octave of negative 12. Distance-wise, what would that be? I'm going to put this first so it doesn't give me an error. It's going to be negative 13 in notes in the backwards direction, I, and then instead of continuing this one on 7, 7 and negative 7, negative 8, I'm going to keep it the same. So that's going to be a 1. Now it should be negative 1, but I don't want to put another negative. The negative is following through. So it's a negative 13, I, negative 1. In other words, I'm going negative 13 steps backwards from the Ionian node, or I'm going 1 step back plus 12 from the Ionian node plus an octave, and it's going to be an Ionian first modal half step, which would be a negative first modal half step, which would be a negative second scale degree, except we don't have scale degrees going backwards. So the modal half step terminology still works going backwards, whereas the scale degrees don't work basically going backwards. And that could give you keeping the flavor that you see here, negative 1i first modal half step backwards. And to get the modal half steps going forward, you take 7 minus 1, which would be 6 going forward, which would be the 7th scale degree, right? So this is actually more consistent. All right, given that, let's see, how can I copy this so I can copy it back all the way back and then copy it across? To do that, I'm going to delete this, and I'm going to look at my formulas when I went forward. When I went up past 11 forward this way, I had an II and 12 going forward. What's the formula? We took this one, and then we said and 12. Let's copy that formula. The problem is that I want it, it's going to go up. If I paste that here, just the formula, it's trying to pull it from up here. So all I need to do is change this to be pulling from down here. So pull it from there. So what's it doing? It's saying pull that II, and then and is a term that links it together to a text term. Text terms need quotes around it, another and, so that all the ands are a little confusing, but don't let it bother you because that's in quotes. That means it's an and this and is tying it together again to 12, which I hard-coded, which means I just typed it, because that's going to be the same for this whole distance. Now this 12 needs to be negative 12, however, negative 12, and there we have it. So that should do it. And so now I can pull that one up, and it should go all the way up to here, ba-boom. And so that looks good. So Ionian, why is there a negative? This one has a negative, oh yeah, because there's a negative behind it. That's why I had to have a, yeah, that's right. I think that's right. I think we have it. All right, and then if I make it go up the next one, I'm going to change it to, make this blue again. And then I want this not to be 12. So now it's pulling from here. So I want to change it to pull from here again. So I want to change this front bit to pull from here. And then boom. So that looks right. But then that 12 needs to be 24. 24. So now it's going II, distance of I to I, and 2. It's going 2 octave differences. 12 plus 12 is 24 in the negative direction. So it's got the same note, but there's 2 octave differences between the endpoints in the negative direction from the point that we're measuring from, right? And so I'm going to copy this up. All right, and there we go. All right, well, let's try this one. So we can do the same thing. I'm going to go down here and copy this bit. So this went I 1 1 and up 12, and then I'll paste it here, and then I'll make this one green. Now the problem with this one is that once again it's trying to pull from up here, so I just need to change that and say I want you to pull it from down here. Boom, that looks right, and then that 12 needs to be negative. This 12 needs to be a negative 12, and same thing. So I can copy that up, boom. And so I think that looks good. And then I'm going to copy it up one more, make this blue again, and then double click in here. Now it's pulling from there. I want it to start over again and pull from here. That's good, but then that 12 needs to be 24. 24, and then I can copy that up. And that should be good. Might not be the best or most efficient way to do it, but that's a pretty efficient way to do it. Now this one gets wonky, because if I go down here, what happened is, what I'd like it to do is I'd like it to take just the end bit, the I and the O, and then I want to put a 1 in front of it. The problem is that how do I get it to just pull that end bit? Usually I can say pull the part from the right side of the equation, but I can't do that because it's not always the same number of units, right? It's 1 unit here, and then it's 3 units. I want to pull 1, 2, 3, 4 units here, and then 2 here. So it's not, and then I can't even go from the left side because the left side is sometimes 1 unit and 2. So I have to grab it from the middle. So we came up with this formula, which basically said, I want you to put this 12 and the mid. Find the midpoint where that I is in the middle of the equation, and then pull everything from that midpoint towards the right. That's what this formula is basically doing. So we're going to pull the I and everything after it, the I and the 0, this one, the I 0.1, and then tie that together with and that 12. Okay, so let's do that. We're going to say, let's copy this one up here and just fix it. I'll paste it right there. And then I'm going to double click on it. So this is pulling from up here. So that cell is wrong on 14. So that this U14 needs to be pulling from down here. Every time I have a U14, it should be pulling from here. Here's a U14, should be pulling from here. And then here's a U14, which should be pulling from here. Boom. And then, so everything else looks correct. So now it's pulling that 12. Okay, I think that's right. Let's make this green. And let's just analyze it a little bit more detailed. What's this doing? This is pulling from that 12. Why is there a $ before it? Because when I copy and paste this to the Dorian and the Phrygian, I don't want it to move to the right. That's what the $ is doing, stopping it from moving directionally on the letters. But I do want it to move up and down. Therefore, the 26 will move up and down as I copy and paste it. We call that a mixed reference. The mid thing is basically saying pull the middle point of the formula, and then we see here the mid text that we want to pull from is in this cell, U31. What do you want me to find in that cell? Because you're pulling the midpoint. I want you to find, then we have another function that we embedded, find the U2. There's U2. That's the I. Find that I. Now, why did I do a U2 up here? Because I want this one to be able to copy forward to this D. Therefore, another mixed reference. The U is allowed to shift, so we can copy it to the right. But the 2 is not allowed to move. That's why the $ is there, because I don't want it to move down. So I don't want this to move down. Mixed reference. And so then within the text. So find that I within this text. And then the len is going to tell us the whole series of text. Find that point in the middle and give me everything in that series of text to the right of it is the whole thing. All right, so that looks good. So it gives me a -12 I 0. So distance backwards -12 from the I node. It's a 0 distance if you think of it as a clock face, as opposed to a distance that keeps going linearly upwards, in which case it would be a -7, right? So then if I copy this up, this one is going to be a -13 I first modal half step instead of a -13 from the I node 8th modal half step backwards. Okay, and then let's copy, this one is going to be then the -14 I 1.5 modal half steps backwards. And then this one's going to be the -15 I -2nd modal half step. I'm not putting another negative, but we're saying that negative's following through, so it's a little bit cleaner we don't need 2 negatives. -2nd modal half step backwards. That -2nd modal half step, again, is giving you the flavor, right? Because that is going to be equivalent to this -2nd, and it'll be easier for me to see the inverse if it went the other way, which would be 7 minus 2, right? Which would be 765, which would be the I 5th modal half step, which would be the 6th scale degree. So this way makes it a little bit easier to see, again, the flavor term on the right side, which is not continually going up, as well as the distance, which makes it more specific to tell you exactly what's happening, right? Where again, if you talk to most particularly guitarists are really bad at being specific a lot of times. It's almost becomes like almost on purpose, right? Just because it becomes a part of lingo or language that, you're in the in group if you know how to say this weird thing. But you'd like to be specific, right? Come up with the terminology that works for you and your group and whatnot. But you'd like the terminology to be more specific, not less specific, right? So that you can more clearly convey the ideas. And I think this is actually the most specific, basically taking what I think the Nashville guys with their number system that is clearly makes sense, and just taking that logic further is what's basically happening here. So -17 Ionian from the Ionian node, -3rd modal half step backwards, and so on and so forth. So if we copy this all the way up, then we've got -23. Now, if I copy it up to the next one, does it still work? I believe it will, even though it's not pulling from, I didn't need to re-pull it down here again because it's still pulling from that midpoint. So it's still pulling the end part of this one, the I and the 0. Let's make that a blue, and then I'll copy this one all the way up as well. So there we have it. So I think all of that works. Now I can just simply copy that whole thing to all of the other modes. So let's copy from here down. Let's make this an I. This should be an I modal range. All right, let's copy this over. And so I'll take this whole thing, and I'm just going to try to copy it. Wait, not down to there, only down to here. And then paste that here. All right, so did that do it right? So this is going to be a DD, a Dorian to Dorian, and -12. That's a Nashville number system, a 2-2 modal range, and -12. And it's a distance of a -12 D, -0 modal half step backwards. -13. This one's a -14, which would be 14 minus 12, it would be -2, or -2 plus 12. D, Dorian, negative first modal half step. Again, I keep on having to say negative because I don't want to type two negatives, because that's just more typing than I think you need if we just assume that that negative follows through. So -14 Dorian, negative first modal half step backwards, right? Which would, and so this would be a -16 Dorian. Let's do this one. -15 Dorian, -7 modal half step, second modal half step backwards, which would be the -3rd scale degree. If there was such a thing as a -3rd scale degree, we can see it going forward, because if it's -2 modal half steps backwards, 7 minus 2 is 5 modal half steps forward, which would be the 6th scale degree, right? So I think it's working. So let's copy both of these this time. And I could copy both of them. And that should cover the Phrygian and the Mixolydian. Boom. Or wait, the Phrygian and the Lydian. So now the Phrygian and the Lydian have been pasted. So here's the Phrygian. So a PP and -12, which is a which is a 3-3 modal range, and -12, which is a distance of -12 Phrygian 0 modal half step, right? And then here's the YY. This is a P. This is a YP. Well, let's do this one. This is a YD, a Lydian Dorian modal range, and -12, which is a 4-2 modal range, and -12, which is a -15 from the Lydian mode, -2nd modal half step backwards. Or it would be a -12 minus 15, 15, 12, 13, 14, 15, -3 minus another 12, minus an octave, Lydian 2nd modal half step backwards, which would be the 3rd scale degree, which means if it was going the other way, it would be 7 minus 2, the 5th modal half step forward, which would be the 6th scale degree, right? So I know that's wonky sounding, but see how it works going backwards and forwards, where this totally doesn't work. This is a mess over here. It doesn't go backwards and forwards. It forces you to to go off of the scale degree. When you're measuring in the backwards direction, people don't know exactly what to do. It doesn't take into account the octaves very clearly. The scale degrees get dropped completely when you go backwards, and it's based on one mode being the primary basis of your measurement when I don't feel that should be the primary basis of the measurement. Anyway, so now we need to do Mixolydian, Aeolian, and the other one, the last one, so I can copy 3 of these. Let's copy from the Dorian to the Phrygian to the Lydian. So I think I got those right, and I just go down to here, copy that, and then just paste that here. Boom. And I think that should do this all the way across. So we've got 24. Okay, let's just check it. So if we're here, now let's do this one. Let's do the ones up top here. So this is an XA modal range and -12. So it's going Mixolydian to Aeolian in the negative direction, which I can tell because I now have a -12 in between them. That's going to give me direction. Whereas if I didn't have that, I would assume it can go either way, right? It's the modal range. So this would be a 5-6 modal range and -12. It would be a modal distance interval, right? Instead of scale degree interval, it's a modal distance interval of a -22 Mixolydian -6th scale degree, which means it would be 12 minus 22, which would basically be 12 minus 20. 12 minus 22 would be, -10. Would be -10 from the Mixolydian mode, and that would be the 6th modal half step, right? And that would be, and so if I wanted to see going forward, it'd be 12. It would be 7 minus 6 would be the first modal half step going forward, which would be the second scale degree if it was going forward, right? And so if I did, and that would be an AN. So how about an Aeolian? So now up here, let's do this one. Let's do one like here. So now we have an AI and -12 modal range. It's going in the reverse direction from Aeolian to the I, and it's adding a 12 between them, which would be a 6-1 and -12 modal range, which would have a distance of a -21 Aeolian -5th modal half step. So that -5th modal half step gives the flavor. If I was going the other direction, going positive direction, it would be 7 minus 5, which would be 2 modal half steps forward, which would be the 3rd scale degree, right? It would be the 3rd scale degree. All right, let's go to this one. This is a Locrian, the crazy one. And so on the Locrian, we have, let's do this one, an ND and -12 modal range, which is a 7-2 and -12 modal range, which is a -21 from the Locrian node, -5th modal half step backwards, which means that if it was going forwards, it would be 7 minus 5, which would be the 2nd modal half step forward, which would be the 3rd scale degree going forward. And this 21 minus 12 would give us 9, right? So we had 9 modal half steps backwards going forwards. That would be 12 minus 9, which would be 3 going forward, right? Like if you understood the logic behind this, you can actually understand the logic behind what I'm going to be calling now. I'm trying to get my marketing down. I'm going to be calling this the modal. You can understand the logic of a modal distance interval versus there's huge gaps in the logic that people kind of find workarounds around when you're dealing with a scale degree interval, right? The modal range and the modal distance intervals makes sense, like a plumber would measure a pipe, right? That would be the cleanest. The the scale degree intervals have problems that you have to work around. You have to figure out how, so you can't get rid of the scale degree, but you might want to add the concept of a modal range, doing the measurement like a good old, woodworker would measure something, and so that you can then figure out what your workaround terminology is going to be when you measure negative directionality and so on and so forth with normal scale degree terminology.